Hello students, in today's video we will be discussing the topic amplitude shift keying. Before this amplitude shift keying, we will just discuss about amplitude modulation and pulse amplitude modulation. You have seen that in amplitude modulation the information as well as the carrier signal both are in the sinusoidal form and the output is also in the sinusoidal form. Output means the modulated signal is also in the sinusoidal form. Whereas in PAM, that is pulse amplitude modulation, your information is in the analog form and the carrier you are using the pulses of high frequency. So the output will be the pulses of varied amplitude. That is what is known as pulse amplitude modulation. Today's topic is amplitude shift keying, in which our information in the form of bits, that is bit sequence is our information, and you are combining these bits with a high frequency sinusoidal signal and giving the output as the either presence of pulse or absence of pulse. Presence of pulse when your bit is 1 and absence of pulse when your bit is 0. So first we will see how you generate the ASK signal and how you will detect the ASK signal. So as you can see, this is the generation part. In the generation part, this is the bit sequence, that is the input which you are going to transmit or the information which you want to transmit. So this bit sequence is given to the balance modulator from one input, and from the other input you are giving the carrier, which is a sinusoidal waveform, let us say A cos omega Ct. So when you combine these two signals, the output will be the amplitude shift keying signal. Okay, so this signal can be represented by, you can say, the ASK signal is represented by A cos omega Ct when bit is 1 and it is 0 when bit is 0. So you will get a carrier signal when bit is 1 and you will get a 0 when bit is 0. When this ASK signal is transmitted towards the receiver first receive this ASK signal, which will be given to a multiplier circuit, and in the second input of that multiplier you are giving the same carrier which you have used at the transmitting end. So this ASK signal, which is A cos omega Ct, will be multiplied with A cos omega Ct, which will give you the output as A cos square omega Ct. Then A cos square omega Ct can be written as A 1 plus cos 2 theta, right? That is A by 2 plus cos 2 omega Ct. This signal is given to this integrator circuit. Here this integrator performs two operations. One, the integrator work is a low pass filter, and this low pass filter removes the high frequency component, which is the cos 2 omega Ct term. That term will be removed and remaining term is A by 2. Either you will get A by 2 or you will get 0, because when the input is 0 or the bit is 0, your ASK signal will give no signal. So multiplied with this will give nothing and the output will be 0. So another operation of this low pass filter is it is maintaining the bit interval. Every bit is having a particular interval. For example, if this is bit 1, if this is bit 0. So from here to here there is a bit interval which is known as TB. So every bit occupies a TB second width. So this low pass filter or the integrator not only removes the high frequency component, but it maintains the width of the pulse, which is TB seconds. Then this pulse is given to the decision device, where with the help of its threshold value, this device will decide whether the incoming signal is BT or bit 1 or bit 0. Because what happens when you transmit some signal through a channel, some noise will be added to this signal. This noise can be additive, this noise can be subtractive. So both case signal can be distorted. So this decision device will give a threshold value, let's say 3 volts. So if the signal is above 3 volt, it will consider it as bit 1, and if it is below 3 volts, it will be considering as bit 0. Okay, so this way you will get the bit sequence which you have transmitted from the transmitter. This is how your basic amplitude shift keying functions. Now there are some advantages and disadvantages of ASK. First, the advantages, its simplicity. As you can see, the circuitry is very simple. So the, you can say, operation is simple. Then second is easy to generate and detect. Generation and detection circuit is easy. So these are the advantages of amplitude shift keying. Moreover, there are some disadvantages. First is very sensitive to noise. As you know, amplitude modulation also sensitive to noise. Pulse amplitude modulation very sensitive to noise. Why? Because in both the cases, what we are doing, you are changing the amplitude of carrier. Whenever there is change in the amplitude, noise will affect more. So that is why amplitude shift keying also is in the same line, that is, you are changing the amplitude, so it is susceptible to noise. Then second disadvantage is it used at low bit rate up to 100 bits per second. Up to 100 bits per second, as you can see, 100 bits per second is a very low bit rate, which is nowadays not in use. So you can say that ASK signal presently is not functioning. So this is the waveform of amplitude shift keying signal. As you can see, this is your bit sequence BT, that is 1101 0011. This is the bit sequence which you want to transmit. You are taking a carrier signal A cos omega CT, which is this. Now when you combine this BT with this carrier signal, the output will be like this: carrier, presence, carrier, absence, presence, absence, absence, presence, presence, presence. So when it is present, when the bit is 1, when it is absent, when bit is 0. So that means you are obtaining a waveform which is known as amplitude shift keying, which is nothing but the absence and presence of your carrier signal. So this is the waveform where you will get either presence of pulse or absence of pulse. So this is what the ASK signal looks like. And one more thing, this ASK signal is also called as OOK. OOK stands for on off keying. So this is another name for ASK. Suppose in the exam they will ask, explain OOK. So don't get confused. OOK is nothing but ASK signal only, because on off means when bit is 1, the signal is on. When bit is 0, the signal is off. So that is why it is called on off keying technique. So this is basically what is called as amplitude shift keying signal. This is a very simple technique. I hope you understand. If there is any doubt or query, you can write it in the comment section.